Hello, my name is Cindy and welcome to this video. This is the 6th video that I am working on for my series in Introduction to Algebra. This is the very beginning concepts of algebra. So this could be for pre-algebra students, Algebra 1 students, and parents, because parents want to know what their kids are doing, right? I love to teach math and I use the traditional approach. So this is actually algebra that I had when I was in school. And I believe it is the best way to do the math today is the traditional approach. And so that's what I will be putting on my channel. So this is algebra and we are going to be talking today about solving equations. It can be confusing if you don't start at the beginning. There are rules that you need to follow when you are solving equations, and I hope that you can see through the many equations that I solved today that it will help you in your beginning algebra concepts. Okay, so today we are going to start with combining like terms. Now, in one of the previous videos, we talked about what terms are. Terms are any number of letters or whole numbers that are multiplied together. And terms can be separated by a plus or minus sign. So terms, it's important to know what terms are. And so here I have some terms. This is a term, this is a term, this is a term, and this is a term, okay? And I can combine some of these, but I can't combine others. So x squared, those are like terms. So what I can do is I can combine those and I add the coefficient, the number in the front. So that's a 3 and I don't see it here, but there is a 1 understood right there. So I say 3 plus 1, I have 4x squared. And now I have 2x plus 5x, those are like terms. So 5 plus 2 is 7. And that is my final answer. I cannot reduce it any smaller. Okay, so I took these 4 terms and I combined the terms that are alike. And then I had to end it at that point. Okay, so let's try another one. Y squared plus 4xy plus 3y squared plus 2x squared. Okay, let's combine like terms. I see a y squared here and a y squared here, so I can combine those. Remember there's a 1 there, so 3 plus 1 is 4, 4y squared. Is there another xy term? No. So I can't combine anything with that. Is there another x squared term? No. So I just write that down here. And we are done. That's as far as I can go to combine like terms. That is the answer right there. It doesn't boil down to one term. The answer in this case is a 3-term answer. Okay, let's try another one. What if I had 1/2 x plus 3/8 y plus 2/3 x plus 1/6 y. Oh my goodness, I have fractions in this one. Yes, you can do it even with fractions, but you can only combine like terms. So I see an x here and an x here, so I can combine those. So I can do 1/2 x plus 2/3 x, and then I can do the y's together, 3/8 y plus 1/6 y. I can only combine like terms. Okay, so now I have to use my fraction knowledge, which when I'm adding fractions, I have to find a common denominator. So I'm going to rename this to 3/6 plus 4/6. And if you don't know how to add fractions, I do have a fraction video on my YouTube channel as well. So here I'm going to do 7/6x, okay, plus, and my common denominator here is going to be 24. 8 times 3, so 9 times 3 times 3 is 9, and this one is going to be 4 over 24, so then I get 13 over 24 y, okay? And I can reduce this to 1 1/6. So 1 1/6 x plus 13 over 24 y, and that's as far as I can go with that one, okay? So that is my final answer, although I'm going to change this to 1 1/6. So there you go. That's it. Now remember, you can only combine like terms. Terms are separated with a plus or minus. Now, if I had something like a squared times a cubed times a, this is actually all one term, but I am multiplying here. So I can combine these by adding the exponents. So 3 plus 2 plus 1 is a to the 6th power. So you can think of this as a times a, and this one is a times a times a, and another a. 1, 2, 3, 4, 5, 6. So I can just add the exponents if I have the same base. But this is all one term. If I had something like this, a squared plus a cubed plus a, I cannot combine those at all. I would have to leave it just like this. Okay? So there's a difference between multiplying variables and adding terms, adding like terms and multiplying like terms or multiplying terms. Okay, so let's try another one. 3x squared plus xy plus 2xy plus y squared. Okay, so here I have xy, I have an x, I have a y squared. Which ones are like terms? The only ones that are the same terms are these, okay? And remember, there's an understood 1 if there's no 1 there. So I say 2 plus 1 is 3. So 3xy for the middle, and then the end terms just stay the same. So that is my final answer. You cannot add them together. You cannot add the exponents. You can only add like terms. So now we are going to do a problem by solving the equation, okay? Solving equations is a really important part of algebra. You are going to solve equations throughout your algebra career, and you have to know all of these different types of rules in order to do so. So first of all, let's start with this one. Remember, the letter stands for a number, and you're trying to find out that number. So if I have the letter X, we want to end up with an answer. X equals something. And we have to be able to put that number into the problem, the original problem, and it should work, okay? So first of all, if I have numbers on one side that I can combine, I can start with that. 25 minus 10 is 15. And now you might be able to see that if I multiply by 3, I get 15. This means 5 times x. But I'm going to show you how to do this algebraically. What we're going to do is we're going to multiply something times 5 to get 1, because 1 times x is that number. So what I'm going to do is multiply by 1/5, okay? So if I multiply this by 1/5, that changes to 1, so I have x alone on one side. 15 times 1/5 would be 3. I could also say it like this: divide by 5, divide by 5. I often do it that way, and just that's how I show it. Divide by 5 on both sides, which is the same thing as multiplying by 1/5. Okay, you just want to do, here I'm multiplying, you want to divide to make 1 in front of the x. And on this side, I get 3. Now I'm going to plug the 3 into the original equation. 5 times 3 equals 25 minus 10. 5 times 3 is 15 equals 15, and it checks out. Now, sometimes students don't want to write the steps. They want to just say, hey, I figured it out. X is 3. Part of algebra is writing out the steps, okay? It's just part of the process for the class. So encourage your student to write out the steps. It is good when the student can reason and figure out the answer, but the process of writing it out is important because that will come in handy for future lessons on other things as well. So please encourage your student to write out the process. And also, when you get to x equals 3, or whatever your number is, you make sure your student plugs it back in to make sure that it works. This is also good, excuse me, this is also good when your student is taking a test in algebra. You can, if they come out with a number, they plug it back in. If they're right, excellent, they know they have the right answer. If they are wrong, they can go back and redo the problem, and that might help them to get to know for sure they got the right answer. Okay, so here's another problem that we're going to do. We are going to do, let's see, x divided by 6 equals 18. Okay, so what would x be here? Well, let's do this algebraically. Here I'm dividing by 6, so let's multiply by 6. Now on this side, that's going to cancel to 1, so we're going to have x by itself. On this side, I have to do the same thing. Okay, that's one thing you need to remember, is do the same thing on both sides. It's so important because sometimes you get ahead of yourself and you're like, oh, multiply by 6, x equals 18. Wait a second, that's wrong. Make sure you do the same thing on both sides. So this cancels to 1. You have x by itself. 18 times 6. 6 times 8 is 48. Carry the 4. 108. Now let's check it. 108 divided by 6 equals 18. 6 goes into 10 one time. 6 goes into 48 eight times. So 18 equals 18, and it checks out. And notice my steps. Again, make sure that your student shows the steps. It is very important. These are easy problems, but they do get more difficult. Okay, so let's try another one. 2x plus 4 equals x plus 5. Now on this problem, we have x's on both sides. And numbers on both sides too. So you just look at it, and let me tell you, you can actually solve these, different ways. There's not one exact way of doing it, okay? As long as you follow the rules. So the first thing I'm going to do is I want to get all the x's on one side and all the numbers, the whole numbers on the other side. So I'm going to subtract 4 from both sides. That's going to make this 0. I'm going to get 2x equals x, and then 5 minus 4 is 1. So x plus 1. Now I want this x over here. So what I can do is I can subtract x from both sides. Okay, so x minus x, no matter what it is, it's going to be 0. So on this side, I'm going to have 1. 2x minus x, remember there's a 1 in front, so 2 minus 1 is 1x, which is x. So the solution to this problem is x equals 1. Now let's plug it back in. 2 times 1 is 2, plus 4 equals 1 plus 5. And here we have it, 6 equals 6, and it checks out. So the problems do get more complicated, but the simple rules are you do the same thing on both sides of your equation. And you could have, I could have done, let's see, I could have done it this way. I could have said subtract 5 from both sides. 2x minus 1 equals x. And then I could say subtract 2x from both sides. And then I end up, since this is a minus 1, you want to make it negative 1. That would change to 0. X minus 2. No, wait a minute. X minus x. X minus x. Yeah. Let's see. Subtract 2x right there. See, I almost did it. I almost did it to that side, not that side. Same thing to both sides. So x minus 2. So 1 minus 2, you have to go into your integers. 1 minus 2 is negative x. Oh, that looks weird. I have a negative equals a negative, but I want a positive x. What do I do now? Well, what you can do is you can multiply both sides by negative 1. Remember, do the same thing to both sides. So negative 1 times negative 1 is 1, and then negative x times negative 1 is x. And see, we got the same answer. So even if you do it in a different order, as long as you're following the rules, you will end up with the same answer. All right, thank you for watching video 6, and I will be making another video with more algebraic equation solving. Stay tuned.